So what do medical physicists actually do? Well, hospitals are crammed full of really complicated equipment. If you compare a picture of a hospital ward from 100 years ago to one from today, you'll notice it's packed full of new technology, systems that are used to monitor how the patient's doing, give them therapeutic drugs, and monitor their response to those treatments. And that's just on a ward. If you go elsewhere in the hospital, there are more complicated treatment and diagnosis machines. And I look after some imaging equipment in the Nuclear Medicine Centre at Central Manchester University Hospitals. Now, nuclear medicine sounds really scary, but it's really not. We inject a slightly radioactive injection into the patient and we watch where it goes, and this injection tracks through a particular biochemical process that we want to study. So if that process is upregulated in the patient, then we will see more of our injection going there. So for example, we use a form of radioactive sugar to study where tumours are, because tumours have a higher glucose transport rate than normal tissues, so they show up as really intense areas on our scans. And our scans are more sensitive to small tumours than scans that just show structure, like CT or magnetic resonance imaging, for example. So my responsibility as a physicist is to make sure that those imaging systems are working as well as they can, that they're giving really good quality pictures that the doctors who work with us can trust when they're making a diagnosis as to what's wrong with the patient or assessing whether they've responded to treatment. And I also look after the software associated with that, all the computers associated with that, all the equipment used to ensure we use our radioactive materials safely. So it's quite a wide range of technology that we're responsible for, but primarily to support this really high quality imaging service. Well, there are two scientists that really inspired me. One was my physics teacher when I was 15. He was called Dr. Janilewski, and he was the man who first told me about radioactivity, about alpha, beta and gamma decay, and how these radiation types can be used in medicine to treat and diagnose disease. And I found that absolutely fascinating, and I remember going home and telling my mum about this, and she said, I think one of your dad's friends does something to do with that. So he's my second most influential scientist. His name's Vivian Witten. He was head of department in medical physics when I was growing up in the local hospital, and he took me on as a work experience trainee when I was 16 and showed me all the different aspects of medical physics, and from that point I was hooked. So I was one of those people who knows what they want to do when I was 16. We're very rare, but we do exist. So as well as working as a medical physicist in the NHS and being mum to two small boys, I am also director of a wonderful thing called ScienceGrrl, which is a network of mainly female scientists who are passionate about passing on their love of science, technology, engineering and maths to the next generation. And I think that's really important, is that we show the range of careers that are available to young people, particularly girls who may not have met someone who's a professional scientist and may not be aware of the range of jobs that it can take you into. I think, from my experience, meeting people who actually do those types of jobs and meeting them and realise they're actually a little bit like me is immensely encouraging, because it shows that someone like me can do something like that. And hopefully by meeting people like me and the other girls who are involved in the project, young women will be able to grasp the opportunities that are available to them through studying science. I think science is inherently a fascinating subject. It explains how the world works, and I don't know how people can't be interested in that. And there's sure to be a branch or a specialism within science that covers something that you find really, really interesting. And also the skills that science teaches you are very useful and very practical. So the ability to analyse a problem and work out ways of solving that problem and testing those solutions and working out what are the best solutions out of many options, those are all skills that you acquire as a professional scientist. and they're skills that can be translated to a wide range of careers. I've got friends who started out in chemistry who are now working in banking, or I've got friends who started out in zoology who are now in medical research. The skills that you learn in scientific training can be applied to a wide range of situations, and I find it's taken me to some really interesting places and got me to meet some really interesting people. I don't think there's anything inherently different about women that would make them less good at doing science, but it seems that even from A-level onwards, women tend to be put off science more than men. So at A-level, there's fairly balanced numbers of guys and girls doing biology, slightly more guys doing chemistry, but physics is really male dominated right from the very start. So maybe for some sciences, there's the assumption that these sciences are more for boys than other sciences, particularly things like physics, engineering and maths. And I think that's mainly a cultural assumption that these aren't girly things to do. Being a physicist, of course, I disagree. But I think all sciences have a problem that women tend to drop out as they go further and further up their careers. So we have very few female science professors, for example, in universities. I haven't got the figures on what it's like in industry. It'd be very interesting to see whether this is something about the way academic careers work and how compatible that is or not with family life compared to a career in industry or, like myself, in the public sector. I've never really felt it's an issue. Me being a woman, I get on really well with guys, so being a physicist isn't an issue at all. And where I work in medical physics is actually very gender balanced. There's a sort of 50-50 split in my department between men and women. And the NHS is obviously a female dominated workforce, so they're quite flexible in accommodating me working part-time so I can spend a bit more time with my young family. It's immensely encouraging to me when people come back and say that I have inspired them to pursue a career in science, or just to realise that science is an exciting and useful thing. I have students with me on work experience quite often, and several of them have gone on to careers in medical physics, and I now see them presenting at conferences, or they come back to me with a research project that they want to collaborate on, and it's so wonderful to think that they started their career on placement with me and now they're at the stage where they're coming to me with their ideas and wanting me to collaborate in their projects and to listen to them present at conferences. I've also, through the schools talks that I've done, had some really nice moments where you just see the light bulb go on almost above the head, and you realise that the penny's dropped and they suddenly get why science is important and useful and fascinating, and even it's something that they can do as a career. I remember a conversation I had with a young lady at a careers event, and we were talking about the different sorts of medical imaging, and she was fascinated by the ultrasound pictures I brought in of my two sons when I was still pregnant with them, and she went away wanting to be a sonographer, the person who takes those images and decides what they mean. And it's wonderful to think that I've inspired her to pursue a career like that, where she can do something really valuable and really satisfying with science. So having sold hopefully 1,500 copies of this beautiful calendar, we're going to have quite a large amount of money to decide how to spend effectively. And there are a couple of projects that we definitely want to do, and one is to fund a team of 6 students, 2 guys and 4 girls, from a school in Tower Hamlets to attend the Mission Discovery Summer School at King's. And these are young people who have a passion for science but don't have the financial resources to attend something like this. The best thing about this summer school is that they're designing a biomedical experiment that will be conducted on the International Space Station. It's an international competition, and the winning entry actually gets taken up to the ISS and done in space, which is so cool. I'm really hoping our team win. So there are a couple of other ideas that we're exploring at the moment. One is an online mentoring scheme so that students can connect with professional female scientists and can ask them what it's like to do a career in science, and whether it could work out for them. We're also going to set up a members forum on our website so that people who are wrestling with maybe issues of balancing their career and family, or how to broaden their professional portfolio to move in a slightly different direction with their career, all those kind of issues that women come up against in wanting to stay within science but not really knowing how it's going to work out. A discussion forum where they can raise those questions in a safe environment and have input from people who've been through the same thing. So those are a couple of ideas. We're actually out to consultation at the moment. If you have a look at the blog entries on www.sciencegirl.co.uk, there's an entry called Moving Forward Together, which has got a link to our online consultation. So if you've got any ideas as to what we should do next, then tell us by the end of January and we'll take them into account when we draw up our proposals for 2013 and beyond.